What is a chemist's favorite sandwich?
What is a what?
I have no
A
idea.
chemist. What's his favorite sandwich?
Wait,
A bolognium sandwich. It's
Uh,
kind of like polonium, but bologna. Anyway, all right. What we're going to do in this video is we are going to predict the products of a double replacement reaction. Now we're dealing with an acid and a base, so it can also be considered a neutralization reaction. The first thing you do when you are trying to predict products in a double replacement reaction is you need to identify your cations and your anions. So in this one, when we break it apart, Na, if we look at the periodic table, it's a plus charge. OH, when we look at our polyatomic ion chart, it's a minus. On this side, when we break this down, H, when we look at the periodic table, it has a +1 charge. And CO3, when we look at the periodic table, it has a -1 charge. So all of the oxidation numbers are, CO3 has a -2 charge. Right, so our oxidation numbers going across the top are 1, 1, 1, 2. In a double replacement reaction, your cations switch places. So that means our H is going to go with the OH, and that gives us H plus OH minus, and I'll just rewrite that as H2O. And then the other one is going to be Na plus CO3 2 minus. When you combine those two together, you get, do your crisscross method, you get Na2CO3. Now the last step we have to do is actually balance this equation to make sure that our coefficients are correct. So here's the things we need to balance. On this side, I'll write down NaOHC, NaOH, and C. And then we need to count them up. We have 1, 4. How many hydrogens? How many carbons? On this side, how many sodiums? How many oxygens? How many hydrogens? Carbons? 1. And I'm going to cross over that because we're not looking at this. So now we just have to balance it. We already have 2 on the product side. Why don't we put a 2 right here? That's going to change this to 2. It's also going to change our oxygens to 5, and it's going to change our hydrogens to 4. Now we have a 2 and 2, 5 and 4, 4 and 2, and 1 and 1. So why don't we skip the oxygens and do the hydrogens? If we put a 2 right here, that's going to change this to 4. It's going to change this to 5. And then everything is balanced. So we have 2, 1, 2, 1. And to sound all super smart science teacher like, the way you would say this is 2 molecules of sodium hydroxide react with 1 molecule of carbonic acid to yield products of 2 molecules of water and 1 molecule of sodium carbonate. If you guys can do that, you are very well prepared and ready to go. And I love you guys too.
What?